Okay, in this video, we're going to talk about displacement. Displacement is the vector that points from where an object started to where an object finished. So it doesn't matter what the path length is, it's just the vector that points from where they started to where they finished. So in one dimension, this is just a number, delta x. It's still a vector, but remember in one dimension, all of the vector nature of a number can be captured in just its sign, so positive or negative. So in one dimension, let's suppose we have a man or a dog or whatever, it doesn't matter, an object that moves 1 meter to the right, and let's call that the positive direction. So this is positive, this is negative. So first he moves 1 meter to the right, then he moves 2 meters to the left. So he's out here, and then he moves 2 meters back to here, okay? So all that matters with the displacement is where he started and where he finished. So he ended 1 meter to the right of where he started. So our displacement then is positive 1 meter, okay? Now this works the same way in higher dimensions. So in 2 or more dimensions, we have to account for the vector nature of the displacement. And so there's 2 different ways to find it. We can either subtract the object's endpoint. So this is the vector that points to where the object was at the end of the movement, minus the initial position of the object. So this is the vector that points to where the object was initially. Or we can add together the sum of many small displacements. So remember, this symbol just means that you add things together. Okay. So let's do an example. Let's say that an object moved. So first he walked a distance of 10 meters at 15 degrees. We'll call that vector A. Then from there, he walks a distance of 12 meters at 91 degrees. We'll call that vector B. And then finally, he walks a distance of 14 meters at 172 degrees. Now, these are all already displacements. We don't know where he started or where he finished. We just know a whole bunch of movements that he made. We don't know where he was when he started walking 10 meters at 15 degrees, or where he was when he finished that and started walking 12 meters at 91 degrees, or where he was when he finished that and started walking 14 meters at 172 degrees. So these things are already displacements. So we look at our formula and we just add these displacements together, and that will give us the total displacement, okay? So in our case, our displacement is the sum of these 3 small displacements, or as we've named them here, it's A plus B plus C. Now, just like in the last example, we aren't giving any reference as to what to measure these angles from. So we assume they're measured from the positive x-axis, okay? Now, we don't have a protractor, so the only way we have to add these vectors together is to add them by components. So when you add a vector by component, to draw it in its own coordinate system, that's the easiest way in my opinion. And so vector A is 10 meters at 15 degrees. So that looks something like this. And so that makes this triangle here. So this distance is AY, this distance is AX. And so AX then is our magnitude, 10 meters, times cosine of this angle from the positive x-axis. And AY is our magnitude times sine of the angle from the positive x-axis. So if you plug this in your calculator, you'll get 9.7 meters for the x part and 2.6 meters for the y part. Now let's do vector B. So once again, we have a new vector, draw it in its own coordinate system. So 91 degrees is somewhere like this. And it is 12 meters long. So we already have the angle from the x-axis. We just plug it back into our formula. So the x is the magnitude, 12 meters, times cosine of 91 degrees. And by is our magnitude 12 meters times sine of 91 degrees. So our x part is negative 0.21 meters and our y part is 12 meters. Notice we're in the second quadrant. And so we got a negative value for x like we should and a positive value for y. So everything is good there. Okay. Now for our last vector, vector c. We want to find its components, so we'll draw in its own coordinate system from the origin. It was at 172 degrees. So that's somewhere like this. So this is 172. And its magnitude was 14 meters. We do the exact same thing we did before. So the x component is our magnitude times cosine of the angle for the positive x-axis. And our y component is our magnitude times sine. So this is negative 13.9 meters, and this is 1.95 meters. Once again, second quadrant, x is negative, y is positive, we're good. Okay, now our total displacement, we said it was the addition of all these vectors, but we can also write it in terms of components, right? So our displacement vector is the displacement in the x direction along the x direction, plus the displacement in the y direction along the y direction. So our delta x then is the x components of a, b, and c added together. And our y displacement is the sum of the y parts of these vectors added together. Now we just found what they were, so we know how to add them together. So our delta x then is negative 4.41 meters. And our delta y is 16.6 meters. Now, just like in the last video, we were given these vectors in terms of magnitudes and angles from the positive x-axis. So we should also write our answer in that form. So we can write the magnitude of our displacement using Pythagorean theorem. So this is the square root of the x part squared plus the y part squared. Just as an aside, make sure you always put these numbers in parentheses because what you're squaring is negative 4.41 in this case, not negative 4.41 squared. There is a distinction there. Okay. So if you do this operation, you get 17.2 meters. And now we also need to find the angle. So if we want to find the angle, we should always draw the vector so we know what angle it is that we're trying to find. So in this case, we'd have a negative x component and a positive y component. That means that it's in the second quadrant. And so this distance is delta y, and this distance is delta x, okay? Now we can find this angle, which is called the reference angle. The angle with the x-axis is always called the reference angle. And so by looking at this right triangle, this is a right angle, we can find our angle here by taking the arctan of the opposite side, which is y, over our adjacent side, which is x. And so in this case, our y part is 16.6 meters and our x part is 4.41. So we don't include the negative here. We just put the numbers as they are. And so if you plug this in, then you get 75.1 degrees. But we didn't start off with a vector from the negative x-axis. We started off with angles from the positive. So we don't actually want this angle. We want this angle, okay? And so we can find that angle by subtracting our 75.1 from 180 degrees because this whole line is a 180 degree angle. So it's 180 minus the 75. That'll give us this angle, which is 105 degrees to 3 sig figs. So our final answer then is our displacement is 17.2 meters at 105 degrees. Okay, so that's how you find displacement.